Good morning, students. Today we are talking about chapter number 4, theories of chapter number 4. Chapter number 4 is called as a magnetic field and its effects. There is another chapter associated with it is called as a magnetic field and its effect or some of the materials of magnetic field. This chapter, whenever we are dealing with the magnetic field, there is one question coming in our mind is that whether we have one magnet, it is having two poles, north pole and south pole, and its magnetic field lines are passing from north pole to south pole from outside, and inside it is passing from south to north. This is the primary thing you have learnt in a secondary or maybe in your 8th, 9th or 10th standard. But today we will discuss about properties of magnetic field because of the current, the product of a magnetic field. The product of the magnetic field and because of the current magnetic field we want to learn. There are some of the name of the scientists called as a very first name which is coming in our mind. It is called as Oersted. You are very much familiar about the experiment of Oersted. He has suggested us that whenever we have one such type of arrangement, one rheostat, it is connected with a battery, one battery supply, one key, and after that whenever current is passing through it, this is key, battery, and this one is called as a rheostat. Whenever you are putting near one magnetic needle, it is just showing us that effect, and that is called as the inclination because it's a movement of your magnet. It means that Oersted has suggested us whenever current is passing, it is producing magnetic field. After learning such type of things, now we are in this position to discuss about what type of effect this may give us. At that time, Oersted has suggested that because of the current we have a magnetic field. That is why we are in position to discuss about so many things which is called as a because of the current magnetic field. It is called as effects. Next one is called as a because of electromagnetism. We will discuss about this one in depth. Electromagnetism. Then we have a measurement equipments. We have a two type of basic equipments we will discuss about. One is called as a ammeter to measure current, and the next one is called as a voltmeter. We will measure voltages. So such type of instruments are there. With the help of that we will discuss that how you can go through and what effect it may occur. Very last one and next one is called as a cyclotron, which is called as a circular motion of our electron with so many higher velocities. So this is cyclotron. Yes, after learning this chapter you will be in a position that if you are saying that because of current you have a magnetic field, there are few scientists who have suggested that because of the magnetic field you may have also the effect of the current. This thing you will learn in chapter number 6 and chapter number 7. Yes, chapter number 7 is called as alternating current and chapter number 6 is called as effect of magnetism or electromagnetic current. So you will learn about one name of this scientist. You may have heard about his name, Faraday, and next one is called as a Biot-Savart's law. After going through some of the passages of this chapter you will learn that how you can say that because of the current magnetic field has been produced. So this is the very first part. It is called as a magnetic field and we are going through the very basic expression of this chapter. First of all, we want to just discuss about the unit of magnetic field. Let's say I have a three-dimensional geometry. I have on one axis magnetic field. It has been represented by B. It is a vector quantity. And let's say I have F. This is also force. It is also having vector quantity. Into this part I am putting my charge. Let's say my electron is moving into the axis. Let's say it is moving with the velocity v with the angle theta. So I can say that it is called as a v cos theta and it is called as a v sin theta. So this much would be the area where there are probability that I can find it out my charge. So my charge is moving in the magnetic field with such amount of a force. So that is having velocity making an angle of theta. Its components are on x component and y component. It is called as a v sin theta. You will aware that in this chapter we will discuss about our movement of charge, because if you are aware about the movement of the charge, you will be familiar with the flow of the current. The very first relation we will just learn about this thing is called as a force is directly proportional to charge. Next one is called as a force is directly proportional to magnetic field, and third one is called as a force is directly proportional to our velocity is a sign component. I am accumulating all these formulas and I can have F equals to, or you can say first of all I'm putting probability, direct function BQV sin theta. I want to just remove this function of equal proportion, so I am putting that constant K. It is called as the equality constant. So I can have a BQV sin theta. So I can have very first expression when I have placed my electron which is moving in the magnetic field and force applied on that with the velocities, that is called as the components. So I got the relationship F equals to K BQV sin theta. Now I want to acquire the unit of B, that is called as a magnetic field. So it is called as a magnetic field. I want to derive its a unit. Let's say I am putting first of all this expression. It is F equals to K BQE sin theta. Assuming that my theta equals to 90 degree, so you are aware that sin 90 equals to 1, and K is called as ideal, it is having value K equals to 1. Let's say my expression would be now BQV. I want to hold this part, B is equals to F divided by QV. Let's say you are aware about F, it's called as a force. Its holding unit Newton, 1 Newton. That Q is called as a coulomb, 1 coulomb, or you can say Q equals to IT, ampere into second. V is called as a velocity. Its holding unit meter per second. If my force is 1 Newton, if my charge is 1 coulomb or ampere into second and my velocity is 1 meter per second, I can say that it's holding the unit 1 Tesla. Or you can place these units Newton, it is coulomb into, that is called as a velocity meter per second. This one is another unit. For our simplicity we are using that Newton is okay, coulomb per second is also okay, and meter. So you are aware that that is -1, sorry. So this would be called as a ampere. So I can have a Newton per ampere meter. This one is the second one. Third one is called as a, instead of this you can place that a coulomb per second and meter. This is going over here. I can have a Newton into second, coulomb into meter. It would be joule per coulomb meter. So such type of units are there, but I'm only interested in finding it out dimensional configuration. So dimensional configuration of our magnetic field, which is called as a famously known as a Tesla. Then later what we will have a Newton per ampere meter. Then you can say then joule per coulomb into meter. Any unit you can use. We will also go to another different type of units. Dimensional configuration of our magnetic field, that is called as a B, which is called as a Tesla unit, and dimensional configuration. Friends, you are aware about the unit Newton, ampere and meter. So I can directly place that M1, L1, T minus 2, ampere is as it is and meter is called as L1. So I can have a Tesla equals to M1, L0, T minus 2, A minus 1. You can recall like that. M1, and that is called as a let's say placing A minus 1 and T minus 2. So this is the dimensional configuration of Tesla. Another unit which we will use widely, it is called as a Gauss. So you can remember that 1 Gauss equals to 10 to the power minus 4 times of Tesla. or you can call it like that. 1 Tesla is equals to 10 to the power 4 times of Gauss. It is called as our electromagnetic unit. Yes, it is a smaller unit compared to the Tesla. So whenever we will use that CGS type of unit to represent magnetic field, we will use that Gauss. It is called as a 1 Gauss equals to 10 to the power 4 Teslas. Last unit to describe our magnetic field is called as a WB. It is abbreviated as WB. It is called as a Weber. So recall like that, 1 Tesla equals to 1 Weber per meter square. Yes, it is also giving you some of the glimpses of magnetic flux. It means that the magnetic field passing through some of the area is called as the magnetic flux. But yes, you must be aware about that 1 Tesla into meter square is called as a 1 Weber. So be careful whenever Weber is useful, Weber is mentioned, must to include meter square. So it is called as a Weber. So now after going through such clip, you are aware about very first is called as a unit of magnetic field, its dimensional configurations, and other units called as a Gauss and Weber. In the next clip we will go through the very first expression of this chapter. Thank you.